Everyone, welcome to a brand new video. So in this video we'll be discussing these basic Python data structures. So these are the built-in Python data structures. There are 4 built-in Python data structures, and they are lists, tuples, dictionaries, and sets. So there's nothing that you need to install. This is completely built into Python. This is part of the core when you're learning Python. So once you just learn the basics, the variables, the for loops, then you go on to data structures and see how you can use them within your code to make your code cleaner, smarter, and better. So without further ado, let's just get started. So the first data structure I'm going to discuss today is tuples. So I'm just going to comment tuples right here just so that we can sort of see what they are, how it's written, and how it works. So tuples are basically some ordered sequences of things. What do I mean by things? So let me just give you an example of some tuples, and then we can just analyze them and discuss exactly how these tuples work. So I'm just going to say tup1 is equal to, so it's going to be 1, 4, 7, 2, 5. Alright, tup2 is going to be equal to hi, hello, and 45. So these are two different tuples. Now, how do these tuples work? So tuples are ordered sequences, meaning 1 comes before 4, 4 comes before 7, 7 comes before 2, and 2 comes before 5. These are ordered. This is the specific order that we have, and this is this sort of sequence. So tuples are comma separated. The items within the tuples are comma separated, and they are enclosed within 2 parentheses. So this is what would tell you that, oh, this is a tuple right now that we're dealing with. What could be inside a tuple is any of the Python types. So the basic Python types are strings, ints, and floats, meaning we can have tup3 actually equal to car, and then 3, and then 4.5. So these are the 3 basic Python types. We can have other types of things within the tuples, but we'll just keep that for later. For now, let's just talk about strings, ints, and floats, so the built-in Python types. And this is sort of how the tuple looks like, comma separated once again, and enclosed in parentheses. So one thing to discuss with tuples, so they're ordered sequences, but what do we mean by ordered sequences? Tuples are basically indexed. So when I say indexed, meaning there are a sort of way for us to access each of these different elements within a tuple, and they're indexed. They have indexes, which are their numberings, so they're numbered. So maybe ideally you would look at something and you'd say that this is the first item, this is the second item, this is the third item. In tuples it's kind of different. So in most coding languages, so if you are coming from a different language, you probably know this, but if you're not, if you're a complete beginner, there's no problem, because if a tuple looks like this, or maybe let me just not confuse you guys. Okay, so it looks like this. There are indexes to each of these elements, meaning the first one is index 0, so this is the 0th element. The second is index 1, index 2, and index 3. So there are 4 elements. The largest index would be the size of the tuple minus 1. So what this basically means is that this is the 0th element, this is the first, this is the second, this is the third, element number 0, element 1, element 2, element 3. This is something very important to keep in mind. It's something very common in most programming languages, so take note of that. So this is the way we sort of access things, and the sort of way that they are numbered and ordered in this tuple. Why am I saying this? Because here's what's going on. So I can actually find out different elements of a tuple using these indexes. So here's how I can index it. So I can just say tup1 is, tup1 sub 0. So tup1 sub 0, and then I print it, and here's what I have. So if I just run this, so tup1 sub 0 is actually 1, just the way you can see it right here. So basically we're saying that the element at index 0 in this tuple, what is it? The output is 1. We can now actually have maybe tup1 sub 3. So in this case, you could probably take a guess what this would be. So just let me run this. And it's number 2. So here we can see it as the 4th element because we're starting with an index of 0. We can see that there are 5 elements. However, if I do try to access tup1 sub 5, I get an index out of range error telling me that this index just doesn't exist. There's no element at index number 5. But you know, you sort of understand the way that it works. So 5 elements, the maximum index is 4. You can actually figure out how many elements are within a tuple using the len function. So if we print len of tup1, and now I run this, I forgot to remove this right here. So let's just run this, and it just tells us 5. However, the maximum index is 4. So I'm stressing on this maybe a bit because, and I'm sorry if it feels redundant for someone who's not a complete beginner, but this is something that beginners really need to keep in mind. So there's another way of indexing things with Python. So you may not find this in other programming languages. However, it is very common in Python and very useful. So if a tuple looks like this, we said that it can be indexed like this. So this is the 0th element, 1st element, 2nd element. There are other ways to index it. So we can just access -1. -1, element number -1, is the last element. Element -2 is the second to last element, and element -3 is the third to last element. So in this case, we have 3 elements. -1 is this one. So in the first case, we're starting from here and we're saying 0, 1, 2. In this case, we're starting from here. So we're saying -1, -2, -3. So now, when we're trying to just print tup1 sub -2, okay, we run this and we actually get the value 2. So this is at index -2, we have the value 2. So -1, -2, -3, -4, -5. So this is sort of how it works. This is how indexes work with tuples. Now, one thing we can do is that we can sort of use these indexes in different ways. So we can use these indexes to sort of slice the tuples. So here's what I mean by that. So we can print tup1, and I'll just do the following. So I have this colon. This colon is used for slicing. I can say tup1 from 0 to 3, and then I can run it. And once I run this, I get this output. So tup1 from 0 to 3 yields another tuple. So this is a tuple, and we have 1, 4, and 7. So these are the elements present when we slice this tuple using this operator right here. Now what does this mean? This means I'm taking the elements starting from element 0, so this one, up until the third but -1. So this is an exclusive function, meaning, so I could literally say 5 here. Even though we said 5 is an invalid index, I could say 5, run it, and get the entire tuple itself. By doing so, I'm saying that this is the exclusive. So it's sort of an upper bound, and we do not go there. So when I say 0 to 1, I'm actually only getting one element, and it's the 0th element, and this is 1. And you can see it right here in a sort of single element tuple. Alright, so this is sort of how we can extract another tuple from one tuple using these slicing operators. So slicing operators are very common in Python. It takes maybe a while to get a hang of it, but once you get comfortable with it, once you get comfortable with slicing the tuples as well as the lists, we'll see later on, this is something that will be really useful for you. Now we can actually concatenate tuples. So here I can print tuple1 plus tuple2. So plus tuple2. And now if I run this, here's what I have. So I have 1, 4, 7, 2, 5, then concatenated with hi, hello, 45. Obviously, if I do tuple2 and then concatenate tuple1, we're just going to get the opposite because here we go. So hi, hello, 45, 1, 4, 7, 2, 5. Alright, so this is how you would concatenate tuples. Now this brings me to a very important point. Tuples are immutable. So we're going to talk about what mutable and immutable are. So when something is immutable in Python or in maybe any other programming language, this means that we cannot change it. Within memory, we have this tuple1. So let's just say in your computer memory, you have this existing box and it has this tuple 14725. Because it's a tuple, it's immutable, meaning this cannot change. So what this means is that I can't just go to that box and change this tuple. When I do assign something else to tuple1, this means I'm taking tuple1 and making it point to another box. And if this is too complicated, allow me to demonstrate in through an example. So I have tuple 1, alright, so tuple 1 exists. Let me get tuple 1 duplicate. And I'm just gonna say that tuple 1 duplicate is equal to tuple 1. And let me just delete this from before so that it doesn't bother us. So this is tuple 1 duplicate. So I can print tuple 1 and then print tuple 1 duplicate. Alright, so if I run them, they show the exact same thing. And in reality, what's going on here is that both of these items are pointing to the same box in memory. So they're both telling this computer to go to this specific box in memory, that's maybe at some sort of address, and extract this tuple. Now what happens if I try to change tuple 1 duplicate? So tuple 1 duplicate is now equal to 1, 2. So this is a completely new tuple, completely unrelated. We can even throw a string in there just to make it, completely different so that no one's confused. Now, what happens in this case, let me just print both of them back again and we'll compare what really happened. So here's what happens. Tuple 1 does not change because the existing tuple in this, box did not get removed. Meanwhile, with tuple 1 duplicate, in the first case, it was pointing to the same existing box. In the second case, what happens is it stops pointing to that box. So it stops telling the computer, I want whatever's in that box, right there in this area. I want to, get something from a totally different box. And in this different box, we have a different type of tuple and it's 1, 2 string. Alright, so it might seem a little confusing. Now, when we go towards lists are actually mutable. This means that they can be changed. So when we go there, you'll sort of understand more how these things differ and why tuples are immutable and how that differs from something being mutable. Alright, so yeah, that's a note on being mutable. Now, maybe a couple last things we can do with tuples. So one thing we can do with tuple is that we can sort them. So here's what we can do. So I can say tuple 4 is equal to tuple 1, sorted, and then open up tuple 1. And I'll just tell you why that is in a minute. So if we run this, I forgot to print, so print tuple 4. Now we run this, we get this sort of list in this case. So it's not a tuple, it's actually a list that's sorted. So I don't want to go too deep into lists right now. But the thing is, in this case, is that what we did was sort the tuple, but because tuples are immutable, we cannot change the existing tuple. We just took it out, we threw it in a list. One last note about tuples is that they can be actually nested. So I'm just going to create tuple 4, and I'm going to create this tuple. So this tuple is going to have an int, it's going to have a word, it's going to have a float, but it's also going to have other tuples. So this tuple is going to have 8, 9, and then it's going to have another tuple where it's like hi, hello. So what happened here is that we actually nested our tuple by doing the following. So we created these parentheses items within this tuple inside the comma separated values, and then we created this tuple. So if I run them, this is what I have. So this is how the tuple looks like, and this is completely okay for Python. Now we learned how to index and access items according to the index. So we said this is the 0th element, this is the first, second, this is element number 3. This entire thing is actually element number 3, and this entire thing is element number 4. Now I'm going to prove this to you by doing the following. So I'm going to print tuple 4 sub 3 and tuple 4 sub 4, and I'm just going to print them, and what we get as an output is these elements actually. Now here's another thing we can do. So we said that these are also tuples, and we said to get the length of a tuple we just need to use the len function. So I can use this len function since the type of these items is actually a tuple. Now the length in both cases is 2, and we can actually perform these functions for tuples. So these are the len, and all the other functions are functions dedicated for tuples. We can perform them and we can actually get a good result. So this is not wrong. Another thing we can do is that we can also do another type of accessing. So I want to access the 0th element in this tuple, and in this case I want to access the first element in the tuple, in the second tuple. Now if I run this, Here I accessed number 8 by accessing the 0th element in the 3rd element of this tuple. Here I accessed element hello by accessing the 1th element in the 4th element of this tuple. So I hope that's clear. I hope you now understand how we can nest tuples, and this can go, pretty infinite. So you can actually just open this up and open another tuple right here, and then just keep going. So this all goes back to you, and then you know how to access them now, because this is sort of how we do it. So I'm just going to move on. So this was tuples. So that's basically it. There's really not much to it. These are how tuples work. Some functions, slicing, indexing, accessing, and all that. Now we move on to lists. So lists are the second data structure that we're going to discuss today. So lists are also ordered sequences. They are similar to tuples in that regard. However, they differ through one aspect, and that aspect is that they are mutable, meaning lists can be changed. They follow the sort of same type of indexing that we saw with tuples, so we'll just see it in a minute. But let's just get started. I'm going to show you some examples of lists. So I'm just going to say list 1 is equal to 1, 2, 5, 3, 9, 2. Alright, so this is the list 1 that I have. List 2 is also the same, so we can have a word, and then a number, and then a float, and then more ints. So this is sort of how they work. So if you're looking at it now, you think, okay, this is pretty similar to tuples, comma separated items or objects, and in this case, instead of being enclosed in parentheses, it's enclosed with these square brackets. So this is how Python, the Python interpreter, differentiates between tuples and lists. So these are how the lists look like. They are also indexed the same way that tuples are. So if we print list 1 sub 2, so we're getting element number 2, and we run this, we get number 5. So this is element 0, element 1, element 2, element 3, element 4, element 5. So this is sort of how it works, the exact same way as tuples, so the same way that we discussed. We can also perform the same type of slicing operations, so we can say we want element 2 till element 4. So this should give us 2. I'm sorry, this was list 1, so here we go, and it gives us 5 and 3 because it's exclusive, like we said. So it takes 0, 1, 2, 3, but 4 is exclusive, so we stop before it. So yeah, this is sort of how it works for now. So now you understand the basic syntax of lists, how to access things within them, and how they look like. But let's move on to the part where it's more important, where we want to discuss the difference between the list and the tuple. So the difference between the lists and the tuples, like we said, is that lists are mutable, meaning you can actually change them. How can I change list 1? So I'm going to show you how I can change list 1. Here I want to just print, list 1, and then print it again for verification. And I'm just going to change list 1 before I even do anything. So I'm just going to list1 dot extend, and then I'm just gonna give it an argument list2, and if it seems confusing, I'm gonna explain it in a minute. So I'm just gonna run this, and here's what I have. So list1, before I did anything, was the standard list1 that I just described right here, so 1, 2, 5, 3, 9, 2. After I extended it with list2, here I have 1, 2, 5, 3, 9, 2, word 3, 1.28. So here I extended it by concatenating list2 to list1. Now, in the case of tuples, when I was concatenating the tuples, I was producing a third new tuple. In this case, there is no third new list. This is list 1 itself, but it just got longer. So this is how it differs between mutable and immutable. Here I changed the lists. So I made list 1 larger and sort of contain more things, and then but it's still list 1, and it's still pointing to the same box. So this is sort of the difference. So if you understand that, then you're good to go. I believe that this is all you need to know with just to differentiate between list 1 and list 2. Alright, between immutable and mutable, like I'm so confused. Okay, so let's just move on. So we learned how extend works. Now how about append? So append looks sort of similar. So append also appends list 2 at the end of list 1. But here's the difference. So I'm just gonna run this and we'll talk about the difference. Here, what happened is list 1 did not get 4 new elements added to it. So in the first case, we added word 3 1.28 at the end of list 1. In this case, we added one new element, and this new element is a list itself. So if we're going back to the same concept of nesting that we discussed before, so when we first started, when we mentioned nesting with tuples, we said that the actual tuple can be an item within a tuple. This is the exact same thing. So when I use append in all cases, it only adds one element at the end of a list. So in this case, it appended this entire list as one element. Extend actually concatenates the list and makes the first list longer. So in this case, if we print list 1's length, so len list 1, also I forgot to mention that it's the same len function that we use for tuples, we use it for lists. And the length of list 1 is actually 7. So we had 6 elements right here, and we added only one element. Meanwhile, if I use extend in place of append, I actually have 10 elements because I added 4 new ones. So I hope that's clear. I hope you sort of get that sort of idea. Now we can remove an element from a list. So what we need to do is just delete list1 sub 2, and now if we run it, we just deleted the element at index number 2, which was the 5 right here. So this is how you would delete an item from this list. Now, one thing you can do with lists additionally, and it's just going to be the last thing we discuss related to lists, you can change a string into a list. So I'm just going to, create a string variable, and I'm just going to have a sentence in it. Hello, my name is, and so this is what I'm going to do. I'm just going to create list3, and I'm going to say list3 is equal to string variable dot split. And now I'm just going to print list3 and show you how this works. So here's what I have. What happened here, when I used the split function on this string, I got a list in return. So this method, you could say, or function, returned a list. And this list contains all the words in that string separated by the space value. So we separated the words and we got each one as a different element within that list. So this is how the split function works. By default, it separates according to the space bar, so this space character right here. Now, whether this was maybe separated by commas, you could say, so maybe here there's no comma, but here there is. So now if I run it again, and here I specify that I want a comma to be the delimiter, you could say, or what's separating the words. If I run this again, now I only have 3 elements. So hello is an element in its own, my name along with the space character before it is an element, and the is with the space and the question mark is also an element in its own. So here we separated by commas. So this is how split works. This is basically all you need to know for lists. So lists and tuples are really similar, except one is immutable, which is tuples, and lists are mutable. So yeah, that's basically it for lists. Now let's move on to dictionaries. So moving on to dictionaries. The way I'm going to explain dictionaries is I'm going to give you maybe an example of a dictionary, and then we're going to discuss it because I feel like it's more clear in that case. So we're just going to say example dict, and I'm just going to create a dictionary and just say name, so name, John, age, 40, year that he was born, 1980. Alright, so this is what we've created so far. So this is a dict. Now, how does this work? So how does this dict work? Why does it look like that? It looks kind of weird. So it's not very similar to tuples and lists. So the way we had these comma-separated values, and they were enclosed in either parentheses or brackets, and it was just, these different singular elements. In tuples and lists, we were indexing things using this numerical index. So we started with 0, 1, 2, 3. So we'd have the 0th element, first element, second element, and so on. In this case, this is sort of different. This entire thing right here is not the 0th element. We're not indexing by numbers. We actually index by strings. So by keys. This right here is a key, and this is a value. This is a key, this is a value. What these represent a sort of table. So another word for Python dictionary is actually a hash table. This is what it's actually called in other programming languages. So keep that in mind. So yeah, this is what it looks like. You should visualize this as a table. So you could see a table that has on the right hand side these keys. So it has name, John. I'm gonna type it actually. So name, John, age, 40, and then year 1980. So this is what the table looks like. So this is just a sort of syntax for that table, where the name is the key, the value is John, the key is age, the value is 40, the key is year, the value is 1980. Alright, so this is sort of how it looks like, and this is how it works. Now, why do I say that these are the indexes? Because here I'm not getting things using the numerical indexes. I get them using these strings. So I can print example dict sub name. And this is actually not an error. So if I run this, actually it is an error because this was supposed to be a colon. So, okay. So yeah, I got John. So getting example dict sub name gives me John because the value for the name key is actually John. And in this case, I'm just gonna copy this, and the type of this item that I return, so if I run this, it's a class string because John right here is a string. It's enclosed in quotation marks. This is how strings work in Python. You probably know this. Alright, now what happens if I get age? So I'm just gonna copy these and get example dict sub age, and then get the type of example dict sub age, and also gonna do these for year. So year and year. So now if I run this, here's what I have. So example dict sub name is actually John and the class is string. Example dict sub age is 40 and this is of class int. Meanwhile, 1980, which also looks like an int, is actually of class string, and this is example dict sub year. Why is that? This is because when we created the dict, so right here in this line, when we created this dict, we used 40 as an integer without quotation marks, and we used 1980 as a string, so within quotation marks. So this is not very concerning, but this is something just to highlight that you can include these different data types within this dict. You could also have maybe someone's age be 40.5 if he's actually halfway there. So this is class float. So this is what a dict looks like. Like I said, this is how we access these different items. We can change a certain, you could say, key, the value for a certain key with this dict. So here's what I can do. So I can say example dict sub name is actually equal to Jane now. So I changed it, and now if I print the dict, so example dict, and run it, the dict now looks like this. So the name is now Jane, the age is 40.5 still, and the year is 1980. So what I did here is that I used this here. So this is not only to extract information, it's also to change information, to sort of assign a value to a key. You could also do this to assign a value to a completely new key. So here's what I can do. So I can just say example dict sub address and just specify this to be New York. And now if I run it, example dict now actually contains this key right here, and it contains the value for it, which is New York. So this is how you would add something new to this dictionary. You can delete as well following this same logic by doing the following. So example dict, actually all we have to do is just delete example dict sub, let's say, address. So I don't want this anymore, and now we run it, and I should have printed it. So here's run it, and now we can see that address is actually gone and it was actually deleted. So you can actually verify whether something exists in the dict by using the keys. So what if I want to know let's remove the deletion. I want to know whether there is an address key in this dict. So whether this, person, you could say record or something, contains the address. So print address in example dict. Now if I run this, I get true. So address actually does exist in example dict. I can say birth year, which shouldn't exist, and if I run this, it gives us false. So this key right here does not exist. Now this only works for keys and not values, so keep that in mind. There's another way, there's actually not another, so there's a way for us to also extract keys and extract values within a dict. So I can just simply print out, let me just delete this, so I can print out example dict dot keys, and this should extract all the keys that I want. So if I run this, here's what I have. So I have dict underscore keys, so this is what they called it, and this is a sort of Python list that we have, and it contains all the keys within it. Now we can iterate over them, so I can actually store these keys somewhere. So let's say keys is equal to example dict.keys, and then I can say for key in keys print key and print example dict sub key. So I hope this is clear. Let me just run this and I'll explain it in a minute. So here I just stored all the keys being name, age, year, and address. Then I iterated over them. So for each key in this list right here, for the first one, this is name, its value is John. Second one, its age, the value is 40.5, and so on. So this is how I managed to iterate over them. Another thing you can do is actually get the values, so you can print example dict dot values, and this is actually the last thing we're going to do for the dictionary, and these are the values in this sort of list right here. So John, 40.5, 1980, and New York. So this is what we have for dictionaries. So far we've covered lists, tuples, and dictionaries. We only have one more Python built-in data structure, and that's sets. So what are sets? Sets are also collections. So what are collections? Collections are basically what you saw in lists, tuples, and now in sets. So sets are collections. They're also, collections of items or objects or values, except here they're unordered. So what do I mean by unordered? This means that there is no specific, indexing scheme that we follow. So there is no 0, 1, 2. So let me just demonstrate. So I'm just going to say set1 is equal to 1, 5, 6. And this is sort of how set1 is. So this is not element 0. These are just existing in the set unordered. So if I had written, 1, 6, 5, this would have still been the exact same thing because it is a set at the end of the day. So the items do not have to be ordered. It does not record element position. So this is exactly what I'm trying to say. One thing to note is that sets, they do not allow duplicates. So they only contain unique elements. So here I'm just going to create set1 and just put 6 again and 8 and more 8, and then I'm just going to print set1 the way it exists in the system. So if I run it, here's what I have. So I have 8, 1, 5, 6, and here it just got shuffled around a bit, but that doesn't even matter because it is unordered. So 8 is not the 0th element. It's just an element that exists within the set. So just keep that in mind. Now, the way it looks, they're also comma separated. So like we said, these collections of items, except here we use these curly braces, but do not confuse this with the dictionaries where we had keys and values. So yeah, the duplicates disappear. Now, one thing you can do is that you can have an existing list. So here I have a list and it has 1, 4, 5, 4, 2, 6, 7, 7. So this is an existing list that I have. I can change this into a set. So I can print set list. So this is a function. Now if I run it, here I changed this list into a set right here. So this is the second set we have, and it removed all the duplicates. So sets only keep unique items. So 1, 2, 4, 5, 6, 7. These are how sets work. You can add something new to a set. So let me just delete this. We're working with set1 now. You can add something new to a set doing set1.add, and you can add a new value. Let's say if you add 8, which is an already existing value, and then print set1, so what happens? Nothing really happens, nothing changes even though we add the value. In the case where I want to add 10 and run this, a new value is added into the set, and the set grows by 1. We can also remove, so here I can remove 8, and this way 8 disappears completely even if there were originally duplicates. So we remove the 8 value, we only have 1, 5, and 6, and sort of this is how we do it. We can also do the boolean verification that we were doing with the dicts, so we can print 6 in set1. This should give me a sort of boolean value, and this says true because 6 exists in set1. I can do the same for 10, and this would give me false. So this is how we basically deal with sets very basically. So sets are, pretty straightforward. There's nothing too confusing. If you understand lists and tuples, you can definitely understand sets. So another thing that we're going to explore, this will be the last thing we explore in this video and with sets specifically. So we're going to talk about set operators. So in sets in mathematics, so sets are actually part of high school math. It's no problem if you don't know them because, it's pretty straightforward, like I already explained, just unique items of unordered values. Okay, so here's what we have to do. We're going to talk about two things, the intersection and the union. So I'm just going to create set2, and set2 is going to actually have 6, 4, and 2, and let's say 5. Okay. So these are set1 and set2. We can print set1 and then we can print set2. So here is what we have. And now, what can we do in this case? So we have these two existing sets. So let me just run this. And these are how they look like after we remove the duplicates from set1. So we have 8, 1, 5, 6. We have 2, 4, 5, 6. So what is the intersection of sets? The intersection of sets is basically creating a third set. So set3. Now we're going to get the intersection of set1 and set2. We do so as follows using the AND operator, so this ampersand right here. What does this mean? This means I'm getting the intersection between set1 and set2. So by intersection, I mean where do they intersect? So if this was a Venn diagram, where do they intersect? What do they have in common? What do they have in common? Actually, they have values 5 and 6 in common. 8, 1 doesn't exist in the first set, and 2, 4 doesn't exist in these. 8, 1 doesn't exist in the second set. This one doesn't exist in the first. So now if I print set3, and hopefully this will be more clear when I do. Set3 is actually 5 and 6. So we created a new set using only the intersection. Now union is actually the opposite. So union is the following. So set4 is set1 dot union set2. Now I can print set4, and I'll show you what union does. Union basically combines these two sets and just takes all the existing elements from both sets and combines them while still removing duplicates. So we don't have 5 and 6 twice in here. We have it once, but we also have 1, 2, and 4, and 8. So these are how intersections and unions work. So this is an AND, you could say. So we're getting what exists in both set1 and set2. In the union part, we're getting what exists in either or. So it either exists in set1 or it exists in set2. So that's basically it for this video. I hope you enjoyed it. I hope it was useful. Let me know if you want some more complex, data structures, algorithms with Python in the comments down below. And if you enjoyed it, please leave a like. Thank you very much and goodbye.